Welcome to a new episode of the MBSE podcast. Today we have a topic I was waiting for a long time personally, because it's also my heritage, how I came to systems engineering. And today we have the topic of MBSE and PLM, and we have a very special guest, and I would say an old friend, at least from Tim. But also I met Erik Herzog from Saab Aeronautics at least once, maybe two times. And yes, I'm very happy to have him here on the show. And yeah, if you're not a subscriber on this channel, consider subscribing the channel on YouTube, on Spotify, on all the sources where you can hear and see us. And we would be happy to inform you if there is another episode. But now, Erik, please introduce yourself.
So, as Christian said, I'm working for Saab Aeronautics, and my role is that of a technical fellow in systems engineering. And in particular, I am working with our process and methodology development, and lately very much again with the area of integrating model-based development approach with a PLM backbone. I'm also president of the Swedish INCOSE chapter and have quite a long background in systems engineering.
All right, so also welcome from my side, Erik. Great to have you here
Thanks.
at the show. So you have a long history in systems engineering, so why is it such an interesting field for you?
Actually, I stumbled into it when I was a PhD student. You know, you get employed and somebody tells you, we have this project, we don't really know what it is. Something about systems engineering. And from that project, starting in '96, I got involved in product data management and the AP233 data exchange standard within the STEP framework. Wasn't the most successful standard, but I got hooked on systems engineering. And I think the main reason is that the ability of dreaming up an architecture, a solution, and seeing an organization step by step making that architecture into something real. And with all the stumbles, the headaches, the setbacks, and the triumphs, until towards the end you see the end product. I think it's so fascinating and so interesting.
Yeah. I think I met you the first time 2005 or so in Hamburg for an INCOSE or German local chapter event of INCOSE about SysML, and you were one of the reviewers of the SysML V1 during that time. Is that correct?
Yes, but I was never a very serious contributor to SysML. It was I was on the outside. I did very little, and to be absolutely honest, I think what you've done in SysML V2 now is just a tremendous step forward. So we met, yes, but no, I didn't contribute much.
But speaking of SysML2, what are the most important trends in systems engineering from your point of view?
Well, from my point of view, we can see models. In the past, we've used them as islands, and we've had our system models, our mechanical models, the analysis models, and the design models in Modelica and Simulink, but they've only been islands. And now we're seeing those islands growing together. We're seeing in-process traceability for all types of system elements. It's becoming enabled. We can see the change management becoming integrated. So if in the past modeling and systems have been separate activities, it's now becoming integrated, and I think we really have to start thinking, how do we put all those models together to create a coherent view of the system that we are developing, or in the end, the system that we have developed and which is maintained.
The first time I had, I'm more used to systems engineering and MBSE, so that's my topic, my world. And the first time I had come into contact with PLM was at a PLM conference, which was about systems engineering. So this was one of the main topics of this PLM conference, and so they invited me to talk about, well, I guess about SysML also. That was quite interesting for me because they had the same similar issues than we in MBSE, but it seems to be a complete separate world. And this was quite innovative during that time, that conference, they start talking about systems engineering. I think at systems engineering conferences, there are not so many talks about PLM, so it's time to merge these disciplines, right? So what is PLM?
Yes, and why are they so separated?
Yes.
But I think for me, PLM is about managing the product data over the life of a system. And product data could be requirements, the architecture description, the designs, and of course the product structures, bill of materials. Also capturing the verification and validation information. How well do we fulfill the requirements? And most of all, in the aerospace industry, we need to declare conformance with requirements and designs, so we know exactly what we are flying. And the other thing also is that keeping track of the changes, the evolution of the system. So and you can go on forever, the management of suppliers, and ultimately in the end, you need to keep track of the individuals, at least in our business, that we produce. What was the actual configuration? And we will ship that to our end users, and they will update the individual configurations over the life of the operational life of the system, of the product. And the product could be a Gripen fighter or an airborne early warning system. So it's extremely important that we keep track of the configurations.
The statements you mentioned sounds a bit like, well, they are directly taken from the Incosi handbook or so. But now you talk about PLM, so it seems to be almost the same, or?
Yes, and same, but from a different perspective traditionally. And if we look at legacy PLM systems, you have this. Typically, you keep track of structures and you manage documents, and you can sign them off and approve them and freeze them. You can create baselines and all the structured changes. And it's really boring. I mean, who would like to work with that? No, of course not, because we really have to do it. But if we start thinking about managing the models exactly as they are, as fine granularity information elements, and keeping track of them, how they evolve, then suddenly systems engineering and PLM becomes one. And the question is really, is it the systems engineering development environments? Are they becoming PLM systems? Or are the PLM systems, are they becoming systems engineering environments? And I think we can see both trends on the market.
Yeah, that's true. Yeah. And from my point of view, I would add that PLM does nearly the same transition like systems engineering, who was coming from a document-based, document-centric approach to a model-based approach, and it's exactly the same for PLM. Yeah.
You mean the shift from managing documents to managing models, huh?
Exactly.
Well,
And I think each community is coming with their heritage. So the solutions are a little bit different, and they are currently aligning themselves. But as when I go to PLM conferences, they have a view on systems engineering which is predominantly requirements and verification focused.
Mm.
But I see a shift there as well. It's becoming more fully fledged systems engineering oriented, but still there are differences in flavor.
Yeah, yeah, absolutely, yeah. Um, so we already had this question in the last 5 minutes, but a trend on the market that I see is that the bigger PLM vendors bought the single SysML applications, for example, and it was a similar thing with all the simulation stuff, which gets bought by one from one or the other PLM vendor. And does it make sense for you to combine those tools? And maybe we first have to distinguish between the concept of PLM and the PLM systems, which are real software, but they are different depending on when they were first invented. So we have also different trends there. How do you see these more monolithic tool environments we are getting right now?
So from my perspective, you can really see the major tool vendors in the PLM market. They are really acting as vacuum cleaners. They are just taking every dust particle, or not every, but very many dust particles that they buy them, and then they slowly integrate them into their own environments. So they are becoming larger and larger and more monolithic. And it's a very appealing prospect for us to just select one and say, this is our PLM environment. We will do everything in it. But then we really have to consider, what is our market? What are we doing? And in Saab Aeronautics, we are doing the Gripen fighter. It's predominantly a Swedish program, but we also have a very strong Brazilian participation. So there we have an international collaboration, and we have to adjust to the best practice which we can achieve in that context. Then the Global Eye airborne early warning system is something we build on our own. But for the T7 trainer, we are a partner subcontractor to Boeing. So each of these programs, which are ongoing, they have completely different business situations. So we would like to end up in a situation where we can pick and choose. So we can pick the best engineering discipline-oriented development environment there is on the market, and combine them, for instance, the best systems engineering environment, the best mechanical engineering environment, the best software engineering environment at a particular point in time, and integrate them, and then create the best possible environment for a particular product. A few years later, the situation may have changed. The partnership may have changed. So if we are put in the same situation, our selections might be completely different. But we would much rather see a federated PLM capability compared to a monolithic one, or one where we have a very strong backbone that really manages all the information, or orchestrates all the information.
In the SysML world, the interchange of SysML models between tools is a big topic. All the discussions about the interchange formats like XMI and so forth. How can an exchange PLM information, or how can I get the SysML information or model stuff into the PLM tool? So are there any standards?
So if you are outside the software world, there are very well-established standards. Oh, so outside the systems world, there are very well-established standards. So for requirements, you can use an application protocol within STEP called AP239. It's very capable in exchanging requirements. You can, of course, also use RecIF. But you can also consider to create integration. If you have a requirements management tool with embedded version management and configuration management capability, then you can actually link from data fragments within that environment to another tool, for instance, using the OSLC standard. So there are really two alternatives. You can exchange information. There are good exchange formats for everything except the models, or you can link, which I think you can always do using the OSLC.
Yeah. And I think therefore we will link the episode with Axel Reichwein we had some months ago. You can find it, I think, here, if we do not forget to link this episode. Yeah,
and of course, as listeners, you should listen to Axel because he has all the right visions.
Yeah, Axel was co-organizer of the OSLC Fest recently, and I saw, Erik, you were also part, and also Tim was a speaker. Was this topic also related somehow to this here, MBSE and PLM?
Yes, very much so. But we took kind of a broader view in that presentation and looking at the overall PLM capability, because yes, we have our systems engineering models, we have the architecture models, the different design models. They need to be linked properly. We need to be able to baseline them together. And then from the design models, we will create executable models, which we can simulate on their own or integrated them with other simulation models to simulate an aggregate. And so it's really about attaining that vision, also having the opportunity to co-simulate, or to build simulation models to simulate more and more complex system or realized systems. So that was also part of the OSLC Fest presentation.
Yeah, great.
Yeah, my talk was a little bit more out of scope. It was not about OSLC. I must admit, I'm not an OSLC expert. So I learned a lot at the fest. But I talked, of course, about SysML v2, so the current status and so forth. Which brings me to the next question. So in SysML v2, for example, the versioning of elements is already built in, and it's not part of SysML v1, but some tools can also provide that for SysML v1. But that's also a task for PLM tools to provide versioning and baselining. So now how does this fit together? If I have my SysML v2 model with versioning and then there's this PLM tool, so who is responsible for the versioning? And do I still need PLM tools? So what's the relationship there?
So from our perspective, when we're looking into federation, we could see the SysML v2 tool coupled perhaps with a requirements management capability and a verification capability, and of course issue management. If you have all of those in an integrated package, you essentially have the basis for a systems engineering PLM capability. And then if you use that as a standalone and integrate it with your mechanical engineering capability, which essentially has all the same capabilities, except that mechanical design is a lot different compared to system design. Then you can have these standalone environments, but you can still integrate them using a few integration points. And especially if these are standardized, it would be quite feasible to create something which is close to a plug-and-play integration.
Yeah, my
So-
hopes are really on the SysML v2 API and services specification, which might help us tremendously.
Which, by the way, is also OSLC friendly.
Yes, there will be an OSLC binding, right?
Yeah.
Mhm.
So, yeah, I think this is a very encouraging development, and I also think that's again why we should look forward so very much to SysML v2, because it puts a lot more meat into the SysML proposition. So it's a real game changer, maybe not from the front end side, but from an industrial capability side. I'm really looking forward to it.
And one thing that I'm wondering in all these SysML v1 server-side managing systems, but also a little bit in the field of SysML v2 API, is that many tools can provide versioning. They can provide some basic rights and roles stuff. Who has read access, who has write access to which package or whatever. But I don't see some kind of release management yet, which is a basic capability of any PLM system, and all the other maturity management capabilities PLM systems have. So, for instance, we will get some kind of release with SysML v2 with the API, so you are able to create a tag. It's very Git-like.
Yeah.
You can create a tag which is some kind of release, but there is no lifecycle state where I can say, please don't use this version anymore because there is a tremendous error in it. Yeah, you always have to look up by yourself, is there a new version of this library that I'm using? On the other hand, it's also not a feasible solution to say I always use latest greatest. And that is the big difference where I say PLM systems with a federated SysML or whatever system architecture language tool, it's still a coexistence possible.
Yes, and you're absolutely right, because PLM, especially when it comes to life cycles and depreciation, it's very mature. We know how to do it, and it would be, I think, a little bit too much to expect that these capabilities are included as in the first release of SysML v2, because it's such a big step in itself. But it's a logical next step to take, to really introduce the capabilities to say that we are putting this thing in the next step of the life cycle. But we're also seeing already today the capabilities to build a product structure, to baseline shallow, and also to baseline deep across the product structure in systems engineering tools. So they are definitely going there. It's just that we see the strengths in the PLM side, where PLM has a very strong heritage. But SysML and systems engineering have a strong heritage more on the modeling side, and it's, from my perspective, the two areas are really converging, and converging fast.
It's very often mixed up, no? And I listened carefully what you said. So you always mention PLM capability, But if people talk about PLM, they talk very often about PLM tools. So they have the tool view and not the capability view, which is quite different, no? And
Absolutely,
and in a perfect world, so no, let's forget how it's now. All the PLM and signal tools, forget them. In a perfect world, if you could decide, would it be good to have a single tool that can handle both? So the systems modeling capability, System L or any other language, plus the PLM capability, or is it better to separate them?
I mean, if in my world, PLM has a mechanical engineering heritage or electrical engineering heritage. So if you look at any capable PLM system today, they would typically have, of course, the data backbone, the ability to keep track of information as it matures and evolves over time, but also the front-end editors. So you could have the ability to manipulate 3D drawings, and it's kind of integrated in a PLM system today, as I see it, or in a mechanical PLM system. So if we say that that's the capability for mechanical PLM, then if I have the data backbone and the systems engineering front end integrated, that could create a systems engineering PLM capability. And if I have a heterogeneous product consisting of hardware, software, electronics, if I just could integrate those environments in a consistent way, I should be able to please my systems engineers by saying, dear systems engineers, I've given you an integrated capability. You have your requirements management capability. You have your system LV2, the verification and validation, and so on. And I could tell the mechanical engineers, oh, you have your mechanical engineering requirements capability, and of course your mechanical design and architecture capability, and of course also the verification and validation from a mechanical perspective. And if I could give them that in an integrated package, they should be happy. The only thing I need to do is to connect the mechanical world and the effectivities and validities of the mechanical world with the validities and effectivities of the systems engineering world. And that in my view, I would do that via product structures. Of course, I also need to maintain requirement traceability. I need to maintain issue traceability. So if I need to implement a change, which is initiated from the system side, I should be able to follow on and see what are the change items on the mechanical side. Or if I find a bug or a problem in the mechanical realm, I should be able to link that to change item in the system side. And then, of course, I need to keep track of what has actually been realized, the individual configurations. But from my perspective, there are not so many integration points between engineering disciplines. Within engineering disciplines, there are many, but not so much between.
And I totally agree, and I think this is one of the most, of the biggest problems we have, that when people are thinking of PLM, they are thinking of BOMs and CAD documents management, and because this is so prominent in the PLM world, or in the connected to the concept or to the tools of PLM, people really have a mental problem to say, we link also other disciplines to it, and it's very funny to see if you're looking on the market, it's always basic capability to say, okay, we can directly manage mechanical CAD. So if you want to also manage electronic CAD or EDA systems, it's totally clear that this is somehow federated, or this is a little bit a different kind of integration, and the same for software. It's still not a standard how to integrate software parts into your mechatronical BOM. And I see that there are a couple of PLM vendors who are on a way to follow a new pattern which they call system lifecycle management. And I think this is there is a need for a new term. Maybe PLM is too negative, too mechanical in many eyes.
I would rather keep PLM. I like it. We're building system, we're building products, and we need to manage them over the life cycle. But
ALM is ALM then the PLM for software?
Yes.
Very much so.
Okay.
But again, from an organizational perspective, I would be very cautious to say that I really buy everything from a single supplier, because this is such a big investment that I mean, Saab Aeronautics, it's a very small organization. We're just about 6,000 people, and the PLM vendors, the big ones, are a lot bigger than we are. So if we invest all our eggs in a single system, the only thing we know is that they own us, and that might not be in our best interest, because we want to be infidel. We want to, if something better comes up in a particular engineering discipline, we would like to have the ability to switch, and switch very quickly. Because what makes ourselves unique is the fact that we are flexible. If you take the big dragons, the ones that are always the OEMs, they can have different strategies. But for us, somewhere in the middle, and we are the smallest aerospace company in the world, of the major ones, I should say, we really need to be one step ahead all the time. And just going from a single supplier, or for a single supplier, we will lose that advantage.
Yeah, that's a good point. Well, coming back to what we said at the beginning, the transition from document-based, model-based, which is important in the systems engineering world and also in the PLM world. Well, to summarize is what we discussed. What do you think is now the way for the future? Maybe is it mentioned in the Incosi Vision 2035? Is there PLM a topic? I don't remember it actually.
Neither do I. Even though we have a meeting at work tomorrow, I will hand out the vision, but I haven't read every page of it, so I'm a little bit ashamed. Very much what we have done in our recent products, it's model-based. I mean, the software, or parts of the software, is model-based. We are doing architecting using SysML. We are doing lots of Simulink, lots of Modelica, and of course everything mechanical is model-based. But except for the mechanical world, we really manage the models as documents, not as individual model elements. So if I take two versions of a design in Modelica, for instance, it's quite difficult to see what has changed. Normally it's just one or two objects or a few parameters. But what we can do is we can say, oh, this is one version of the file, and then it's the next one. So the ability to integrate and see these are the exact changes. This is who did it, when did it happen, and what are the consequences for the traceability to other elements. It's really an enormous impact. So this is really what we are looking forward to, the ability to really integrate stuff and to provide the full picture and the ability of having the engineers, the project managers, and the configuration managers all looking at the same integrated data set.
Mm-hmm.
Because I'm so sick and tired of people reporting on a PowerPoint. This is the status. Because by the time they report, the status has changed.
Mm-hmm. Yeah. 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 But another question for you. So you mentioned the configuration managers and basically the granularity of data, and I had interesting discussions in the past because I'm really in favor to manage SysML models on an element level. And there were dozens of people who told me, oh, this is too fine granular, you can't manage this, manage it on a package level. Where I say, I don't believe that this kind of traceability is enough. So what is your opinion on this?
I think you are absolutely right, but we also have to make the distinction between on which level we keep track of evolution and which are our configuration items.
Yeah.
So, I mean, we really need to keep track of the evolution, what has changed, and so we can also do diffs and merge and so on. But the configuration management could be performed at a system node level. So, for instance, the fuel subsystem or the fuel equipment. But still we have to have the very detailed models and to see the traceability between elements, traceability between requirements and design, requirements and architecture, and of course also requirements and verification. And also keep track of the changes. So you are absolutely right.
The changes of a package is, but it's just I remove files or I remove elements or I add elements to it. That's the changes of a package. But I'm interested in the changes of the elements itself. Not like I changed the state machine or whatever in the model, but that's not part of the changed state of a package.
Yeah, exactly. Yeah. And a very good example is what you basically mentioned right now. The traceability to say a requirement changed, something in this package, you can look it up in your special tool. That's not what we need. That's not what we want.
No, because then engineers still have to play Sherlock Holmes.
Yeah, exactly. Mm-hmm.
Okay, so, well, we talked already a lot about PLM. Now, something completely different. You are also co-organizer of the Nordic Systems Engineering Tour. And I can answer the question myself because I'm also a co-organizer. But
yes, I mean, who shall talk now, Tim?
You are the guest. So can you tell us more about it and what are the plans for next year?
So next year we are planning for 2 tours again, 2 3-day tours. So it's the opportunity for you, anyone who's interested in presenting something on systems engineering or related, make it PLM. I will certainly be in the audience. Over 3 days, in 3 cities, in 3 countries, for 3 audiences. So it's really an opportunity to present one of your favorite topics and travel to different locations and meet different audiences. It's extremely takes a lot of energy, but you also give a lot of energy. And next year we have a spring tour. Tim, you have to help me with the dates.
Yes, end of May, 22 to 24. I think it's Monday to Wednesday, but I'm not sure. But it's 22 to
Yeah, I
24.
think you are right. So that would be from Helsinki over Stockholm to Oslo, and then we have an autumn tour from Linköping to Copenhagen to Hamburg in
September.
In September.
Yeah, 20 to 22, and
Yeah.
I think that's Wednesday to Friday.
And the presentation format is based on just a title and an abstract. But I know, and I hope a lot of you listening are preparing your papers for next year's INCOSE events. And of course, we invite you very much to present also at the OSLC Fest. It's an opportunity to reach out to the people who are not normally going to the larger INCOSE events. So we're really providing a service for them, which is very much appreciated.
Yeah, and I have to say I already had the honor to be one speaker in the, I don't know if it was the autumn tour, but it was the tour Linköping, Copenhagen, Hamburg in this year. And yeah, it was really fun. And I had more or less a PLM topic back then. It was why model management matters.
It does.
Yeah, and it sounds promising. I still think about handing in a paper at the INCOSE symposium. And yeah.
Deadline December the 14th. So we have to sharpen our pens.
Yeah, and we heard from Ralf Hartmann that the deadline will not be extended this time.
Oh, okay.
I'm afraid he's right. So, I mean, it's we are becoming we are getting a president of INCOSE, which is of Northern European origin. So you don't move deadlines; you just deliver.
Yeah, so
I think we should close the session with that. And this time we already know the next topic. Huh?
yes. That's
Last
true.
time we were not so planned, but this time we already know it. And we will talk with Daniel Siegel. He was already on the show a year ago or so, and we talked about a tool, Lemon Tree. And this time it's not about a tool, it's in general about all the system interchange options. Very hot topic, sometimes very emotional I think, for some people. So, well, maybe we'll also talk about OSLC during that time again a bit. And it's next month, December the 13th. So join us if you like to see it live, or you can also listen to it afterwards. And well,
But Tim, since it's on December the 13th and you have a Swedish connection, you know that this is the Lucia Day.
oh,
So I think the task for you is to sing a few Lucia songs for the
my God.
introduction.
And a candle, right? With a candle?
A candle, yes, and well, look it up, and you find that Swedish people are really strange.
Okay, good to know what to
Okay.
expect from Tim.
Yeah, but we will see.
Yeah, I heard a promise.
No. Okay, so let's close as usual, so that we do not forget.
Trust us, we are systems engineers.
Okay, thank you.
Goodbye.
Bye-bye.
Thank you, Erik.
Bye
Thank
bye.
you, Erik.